Okay, second video for Review 5 in college algebra, and we just did, at the end of the last video, we just did example 3a, and so now we're going to do example 3b, and I hope going over these examples helps you, and I don't just follow step by step of what the book is doing. I kind of just do the work and explain myself as I'm going. So if you look at the examples in the book, you'll find out that they're doing them different. They're getting the same answer. I guess they're kind of doing the same thing, but they're going into a lot more detail than what I am. So if you look at part A there, they're taking the 4x cubed and they're changing it to, instead of 4 on the top and 2 on the bottom, and just going 4 over 2 is 2. They're doing 4 is 2 times 2, and 2 is 2 times 1, and canceling, and it gets to be, to me, kind of confusing. But maybe it works easier for you that way. All right, so let's go ahead and top is simplified. Can't do anything with that. Bottom is a trinomial, so I'm going to try to make it into two binomials. There's really no guarantees that it's going to work, but in this case, it again does work. Okay, so one of the things that you'll notice is I have a 2 minus x and an x minus 2. So I have the same numbers and letters, they're just in a different order. This x is a positive, this one's a negative. This 2 is a negative here, and it's a positive here. So what I'm going to do is I'm going to switch these around, and I'm going to keep the signs with them. And I'm just going to rewrite the bottom. Okay. I would like to cancel this and this out, but I can't because the signs are different. So what I'm going to do, remember, if I pull a negative out and make parentheses, it changes the sign of everything in there. When I put a negative in, it changes the sign. So remember what I'd said earlier in a different lesson. If you put a negative in or pull a negative out of a parenthesis, it's going to change the sign. Doesn't matter which direction you do. Pull it out, put it in, it's going to change the sign. So I'm going to pull that negative out, and that makes the x positive now, makes the 2 negative. Because notice if I put it back in, negative times x is negative, negative times negative is positive, so it would switch it back as soon as I put it in. And what that does is allows me to cancel that with that. So what do I have on top now? I have a negative nothing. Well, there's always an assumed 1. You cannot just have nothing in the numerator or the denominator. There's always something in there. So that gives me negative 1 over x plus 3 as an answer. All right, so one of the things I want to bring up, and I don't want to confuse you, so I'm not going to go into a lot of detail, but one of the things I want you to recognize is that this, and this are all equivalent expressions. They're all the same thing. It's just these things here are not simplified, and this is the simplified version of this. All right, one of the things I want you to look at, though, is let's look at this one here. Put a box around it. And this here. Now, what did I say? I said that they're both equivalent, right? It's just this one is more reduced or factored than this one is. Let's look at the domain up here. What numbers can x not be? X cannot be negative 3, and it cannot be 2. It cannot be a number that makes the denominator 0. If this were a negative 3, it would be negative 3 plus 3 is 0. 0 times whatever this is 0, right? If x was 2, it would be 2 minus 2 is 0. 0 times this is going to give me 0. So these two numbers do not work for this expression. Well, let's look here. What number does not work here? The number that does not work here is negative 3. Does 2 work here? Yeah, 2 plus 3 is 5. That does not make your denominator 0. So negative 3 does not work here, and it does not work here. 2 does not work here, but it works there. Okay? So, just something to consider, and the only reason I bring that up right now is we will get into it a little deeper later, but I just wanted to make that observation right now. All right, let's go on to example 4. So example 4a, and one of the things I want you to notice, we're going to simplify this numerator, this numerator, this denominator, this numerator, this denominator. Then we're going to multiply. Always do the simplifying, always do the factoring beforehand. All right, x plus 4, x minus 3 cannot be simplified. It's already as simple as you can go. X minus 9 is the difference between two squares. Square root of each term with a plus or minus between them. X squared minus x minus 2, we're able to simplify that into two binomials. So x, let's see, we have a 2 and a 1 and a minus and a plus. Okay, you can just kind of look at that and know what it factors down to. So this is, everything is factored as I can go. Now I start canceling. So what do I cancel? This time sign, I can cancel across it. So I can cancel this x minus 3 with this x minus 3. One of the things that's very important here, this minus sign locks these two terms together. Okay, I cannot cancel, let's say for instance I had an x right there. I could not cancel this x with this x because this is locked to the 3. Anytime you have a plus or a minus sign between two numbers or two letters, it locks them together, and you cannot ever cancel just the x or just the 3. You have to cancel the whole kit and caboodle. Alright, so I went ahead and canceled that, and I end up with x plus 4 on top and x plus 3 because there isn't anything else that I can cancel. And that ends up being my answer. And it doesn't do me any good to multiply using FOIL, multiply these and multiply these. The only reason you use these different methods is you're trying to simplify more. Well, it doesn't simplify. So just doing the FOIL method just makes it more messy. Okay, so when you've got it simplified, leave it that way. Don't think you have to just go on and on and on. All right, so let's look at example 4b. And I'm going to turn this off and write the problem down so I'm not wasting time. Okay, so there is the B portion of example 4. And again, we're going to look at each one of these pieces and simplify. Okay, so one of the key things when you're multiplying or dividing fractions, and I'm not going to go into the why this works. If you want to know why, let me know and I'll take 10 or 15 minutes to explain. But you've learned that when you divide fractions, you change this to a times and you invert this. You flip it over. Okay? So there is a good reason why you do that, but we're not going to go into the whys. So I'm going to just, right now, before we go any further, I'm going to change that to a times and flip those over. So I'm going to pause while I do that so that when this comes back on, they'll already be flipped. Okay, so they're flipped. So let's go ahead and rewrite these figured out as far as this is the difference of two cubes. So that can be written as y minus 1 times y squared plus y plus 1 using the formula that you've learned. And y squared minus 1 is the difference between two squares, so I'm just going to write them like that. And the second set of parentheses can be written as 2 y, 1, 1. Add those together, you get 2. Multiply them, you get 1. So that works. Over. And we're going to write this as two parentheses, supposedly. But you'll notice that you can write this parenthesis and this parenthesis. But two numbers multiplied together give you 1 and added give you 1. I mean, the only two numbers multiplied together give you 1 is 1 and 1. And when you add those, you get 2. So this one cannot be reduced. So we're going to go ahead and leave that as is. Okay, so one thing to remember, you're going to get into these, you're going to go, wait a minute, I can't figure out how to reduce that or simplify it. What am I doing wrong? Sometimes nothing. And lo and behold, that is the same as that, so they can be canceled. That cancels with that, that cancels with that. So we're left with y plus 1 from right here, and we're left with nothing on the bottom, so an assumed 1. So y plus 1 is the simplification of this big monster up here. Okay, in this next section, we're doing adding and subtracting of these rational expressions. Alright, so if you remember, when you're adding and subtracting fractions, you end up with the joy of common denominators. So you cannot combine these things. You can't. Alright, so let me go ahead and write this one down. And we're going to add it to x plus 4 over 2x minus 2. Okay, we cannot combine these two until we find common denominators. So again, the first thing we're going to do, and before we find common denominators, is we are going to simplify. So let's go ahead and simplify this thing. All right, what we're doing is simplifying just the bottoms right now because we're looking at common denominators. In fact, x squared minus 4x plus 4, when you do factor that down to x minus 2 times x minus 2, you're not going to be able to cancel anything, but let's go ahead and leave it that way. Factor it down to that. And the bottom here, we're going to factor that down. I'm going to assume you know how to do this. I'm not going to go through all the how-tos with you because we've done it enough. Alright, and this is going to stay x plus 4 over, we're going to factor out a 2. Alright, so is there anything we can cancel? No, there isn't at this point, because remember, even though there's, well, even if I could cancel here with something up here, because this is a plus sign, I can't go across a plus sign. If this was a multiplication sign, I could cancel things here and here. But that's not the case, so I'm not going to. So anyway, before I can add these two fractions, I have to have common denominators, and this is the way I teach it. So if you've learned this another way, that's good, but I'm going to show you a different way to do this than you probably learned. What I do is I look at what my denominators are. I've got two different pieces of a denominator here and two here, a 2 and an x minus 1. So what I do is I look at this denominator and I say, all right, what am I missing here that I have over here? I have an x minus 1 there and I have 1 there. So I'm not missing that, but I'm missing a 2. I've got a 2 here, but I don't have a 2 over here. So I'm going to multiply top and bottom by that 2. And now I have a 2 here and a 2 here. So remember, whatever you do to the bottom, you have to do to the top. So looking over here, is there anything I'm missing here? Well, I've got a 2 and a 2, an x minus 1, and I'm missing a 2x minus 1, so I'm just going to put 1 there. And 1 on top. There. Now I have common denominators. So, what do I have on the top at this point? I've got a 2x squared minus 8x plus 8 on top. My bottom is the 2 times 2x minus 1 times x minus 1 plus, and I'm going to multiply these two, and I get 2x squared plus 7x minus 4 all over again. Okay, now since I have common denominators, I can combine those. Over my one denominator. Okay, and I'm done. All right, common denominators. Let's do B, and we'll do that on the next video.